Hey students, Steve here, coming to you from a bar somewhere in northern Michigan where I have good internet. So today I want to talk to you about activity 11-2. I'm going to break it up into two parts because there's sort of two big ideas there. And what 11-2 is it's a look at the random babies problem from the standpoint of theoretical probability. Okay, so let's dive into it. All right, so how do we calculate probabilities? Remember that probability, the probability of an event, is the long run proportion of times that it occurs, right? When we're talking about how likely an event is to occur, we're talking about how often in terms of proportionally it's going to occur if we do trials over and over again. Okay, we have two different ways, fundamentally different ways to calculate probabilities. One way is approximately, and that's what we've done so far with the random babies problem. We do a simulation, right? We do lots and lots of trials, and then we calculate how often some event of interest occurs, and then the proportion is our estimate of the probability. Right? That's one way to do it. The second way to do it is by calculating theoretical probabilities. Okay? So what we do is we list what we call the sample space. And the sample space is the set of all the possible outcomes. All right? Really important, we want to make sure that those outcomes are equally likely. Okay? And then what we do is we identify which of those outcomes correspond to our event of interest and calculate our proportions that way. All right? That's a little bit of a mouthful, but we'll get some practice with it and you'll see what I mean. All right? So let me switch cameras. Right? And let's look at the random babies problem. Okay, so if you remember the random babies problem, we had 4 families, 1, 2, 3, and 4, and then the nurses returned the babies to the parents in some random order, right? So there's baby, 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 baby. Okay, and then sometimes the baby matches the parent, and sometimes it doesn't, okay? And one of the things we were interested in was in asking all kinds of questions about how often or how likely a particular number of matches is to occur, right? So in this example, we can see we had 2 matches, right? The baby 2 matched parent 2 and baby 3 matched parent 3. Okay, or mom 3. All right, so the questions we were working on in activity 11-1, we were able to answer based on our computer simulation, right? What's the probability that none of the mothers got the right baby? What's the probability that exactly 1 or 2 or 3 or all of the mothers got the right baby? And so on, right? And we based our answers on computer simulation, right? Using estimates that way. And just as a reminder, the way we did that was we used the random baby applet, right? And we did a total of 1,000 trials. And in 368 of those trials, we didn't get any matches. In 340 of the trials, we had 1 match. And 245 times we had 2 matches. And 47 times we had 4 matches. And we didn't have any times when we got 3 matches because that's impossible, right? And then we calculated the proportions, and those were our estimates of the probabilities, right? So these are the approximate probabilities, right? So based on our experiment, right, about 37% of the time you can expect you're not going to get any matches, right? So the chances of getting no matches is 37%, okay, based on our experimental work and so on, okay? All right. So what we want to do now is we want to calculate theoretical probabilities. So what we're going to do is we're going to write down all the outcomes for the scenario, right? Now, I have to be careful, right? Because you might think to yourself, well, let's make this our sample space. Okay, my sample space is going to be no matches, 1 match, 2 matches, 3 matches, or 4 matches. Those are outcomes, right? But they're not, right? They're not equally likely, right? We know that you're much more likely to get 0 or 1 match than 2, 3, or 4, right? These are not equally likely outcomes, so we're not going to use those. As our sample space, okay? So we have to be a little more sophisticated in talking about our sample space, okay? So what I want to think about one more time is how these lay out. Okay, 2, 1, 3, 4. Okay, so the mothers are laid out there, okay, and then there's the scenario that we had in our random trial, right? This is one outcome, 4, 2, 3, 1. That was one way that the babies could have been returned, okay? Here's another way the babies could have been returned. 4, 3, 2, 1, right? So what we can do if we're looking for the sample space is we can look at all the possible ways that we can rearrange those numbers, 4, 3, 2, and 1. Those are all equally likely, right? Okay, so let's make a list of those, and that will be our sample space. Right. I remember those. All right, so one way you could do it is we could lay them out 1, 2, 3, 4. Right, that's one way that I could have laid out those numbers. Right, and in that scenario, I've got four matches. That would be perfect, right? It doesn't happen very often. Okay, here's another one. 1, 2, 4, 3. Okay, so switching those last two. That's another way we could have laid out those numbers. Right? Okay, now if you haven't tried this yet on your own, do it. Okay, pause the video and see if you can lay out write down all the possible ways that I can mix up those numbers 1, 2, 3, and 4. Those will make up our sample space. Okay, and then come back and check. Okay, but I'm going to keep writing. So we have 1, 2, 3, 4, 1, 2, 4, 3. We could have 1, 3, 2, 4, or 1, 3, 4, 2. We could have 1, 4, 2, 3, or 1, 4, 3, 2. And I think that's all the ways you could do it where 1 comes first. Okay, there's 6 of them. All right, now let's lay out all the possibilities where the 2 comes first. So we could have 2, 1, 3, 4, or 2, 1, 4, 3. We could have 2, 3, 1, 4, or 2, 3, 4, 1. We could have 2, 4, 1, 3, or 2, 4, 3, 1. Okay, and those are the 6 ways 2 could come first. All right, and maybe you're catching on. Really have to write these things down in an organized way. But you can see there's 6 ways that the 1 could come first. There's 6 ways that the 2 could come first. There's going to be 6 ways that the 3 comes first and 6 ways that the 4 comes first. So we've got 3, 1, 2, 4, 3, 1, 4, 2, 3, 2, 1, 4, 3, 2, 4, 1, 3, 4, 1, 2, or 3, 4, 2, 1. Okay, we have 4, 1, 2, 3. We have 4, 1, 3, 2. We have 4, 2, 1, 3, 4, 2, 3, 1. We have 4, 3, 1, 2, and 4, 3, 2, 1. And those are all the possible ways that I could have laid out those numbers, right? So this is our sample space, and it's a set, right? So it's a set of all the outcomes. It should probably have commas in between because it's a set. But the point is, these are all equally likely. Okay? All right. So now let's count, right? We've got to figure out how often each of the number of matches occurs, right? How often do we get 0 matches? How often do we get 1 match? So we're going to find those probabilities, okay? So sorry about the background noise. So we've got 1, 2, 3, 4. As we said, all of those match, right? I'm going to draw some barriers here so that I don't get confused. Okay. And then let's see. So then 1, 2, 4, 3. The 1 and 2 match. So I've got 2 matches. 1, 3, 2, 4. The 1 and the 4 match. So I've got 2 matches. 1, 3, 4, 2. I think I just have the 1 match. 1, 4, 2, 3. Just have the 1 match. 1, 4, 3, 2. The 1 and the 3 match. So I have 2 there. Okay. All right, now let's do 2, 1, 3, 4. The 3 matches there and the 4 matches. So I've got 2 matches. 2, 1, 4, 3. Not seeing any matches there. 2, 3, 1, 4. The 4 matches. So there's 1. 2, 3, 4, 1. I got no matches. 2, 4, 1, 3. I'm seeing no matches. And 2, 4, 3, 1. Just the 3 matches. All right. Now onto the 3s. 3, 1, 2, 4. Let's see. The 4 matches, and that's it. 3, 1, 4, 2. Not any matches. 3, 2, 1, 4. The 4 is matching, and the 2 is matching, so I got 2 matches. 3, 2, 4, 1. The 2 is matching, and that's it. 3, 4, 1, 2. Nothing's matching. 3, 4, 2, 1. Nothing matching. Okay, last row. 4, 1, 2, 3. Not seeing any matches there. 4, 1, 3, 2. The 3 is matching, so I got 1. 4, 2, 1, 3. The 1 is the 2 is matching, so I got 1 match. 4, 2, 3, 1. The 2 and the 3 are matching. That's the example we had. 4, 3, 1, 2. No matches. And 4, 3, 2, 1. Also no matches. Okay. Whew, that's a lot of work. Almost done though. Almost done. Okay, now we just have to count how many times each of these occurred, right? Again, count carefully. So how many times did we get no matches? 1, 2, 3, 4, 5, 6, 7, 8, 9. I got 9. Okay. How many times did we get 1 match? 1, 2, 3, 4, 5, 6, 7, 8 times. Okay. How many times did we get 2 matches? 1, 2, 3, 4, 5, 6 times. How many times did we get 3 matches? None. How many times did we get 4 matches? Just the 1 time at the beginning. I can write those down a little more clearly. 9, 8, 6, 0, 1. That's an 8. Okay. So altogether, you can see we had 24 elements in our sample space, and if I add across, 9 and 8 is 17, and 7 is 24. So we took care of all our possible outcomes. And then to calculate our exact probabilities, we just have to find the ratios, right? Find the proportions. So 9 out of the 24 times we got no matches. So our exact probability is 9 over 24. And if you punch that in your calculator, that comes out to be exactly 0.375. Okay. 8 out of 24 is a third. So that's 0.33 repeating. 6 out of 24 is a quarter. So that's 0.25. 0 out of 24 is 0. And 1 out of 24 is just about 0.0416 repeating. Okay. All right. If you add up all those probabilities, add up all those fractions, you get 24 out of 24, so you'll get 1. All right. Okay, so we covered all our possibilities. All right, so those are our theoretical probabilities. So this says that you have a 37.5% chance of getting no matches, a 33% chance of getting 1 match, a 25% chance of getting 2 matches, and just about a little over 4% chance of getting 4 matches. And look how that compares to our what we found in our computer simulation, right? It was pretty good, right? 37% versus 37.5%, 34% versus 33%, close to 25%, and close to 4%, right? So our simulation gave us a very nice approximation.